Hi guys, and welcome back to the ACE Academy. In this video, I will be introducing you guys to the topic of grade 11 functions. Now, as you guys may have noticed, at the beginning of this playlist, I have put down the grade 10 functions revision and summary. And the reason behind that is that this section is a progressive section, meaning that in order for you guys to do well in your grade 11 and 12 functions, you will have to have the knowledge that you learned in grade 10. Because majority of this section is taught in grade 10. In grade 10, you guys learned about the four standard functions that we work with, which is the linear function, the parabolic function, the hyperbolic function, and the exponential function. You guys learned their natural shapes, you guys learned their natural equations, you learned how to manipulate the shape of the function itself, and you learned how to manipulate its position vertically, a vertical shift, which was obtained by manipulating its q value or adding a constant to the equation. In grade 11, we will be focusing on the horizontal shift. Now, this section is primarily important as it allows us to utilize the full 2D space, the full 2D capabilities of our Cartesian plane. And in order for you guys to understand this well, I'm going to introduce it to you with a block on the Cartesian plane, with a square on the Cartesian plane, right? I'm going to show you guys how we manipulated its vertical position, and then I'm going to go on to show you guys how we will manipulate its horizontal position, and we are going to apply this basic fact to all the functions as we progress. So guys, looking at your screen right now, you can see that I have a little blue square on a rather large Cartesian plane. I'm going to define each corner of this square. So this square has four corners, and the corner A has the coordinates of an x value of 3 and a corresponding y value of 5. The corner B has the coordinates of an x value of 6 and a corresponding y value of 5. The corner C has an x value of 3 and a corresponding y value of 2. And the corner D has an x value of 6 and a corresponding y value of 2. Now, if I were to manipulate this square such that the square is moved, let's say, 3 units upwards, I would manipulate the y values of each corner of the square, and that should induce a vertical shift. So let's shift this square down by 3 units. Okay, if I were to shift the square down by 3 units, I would subtract 3 from all my corresponding y values. So it would now become y minus 3. So let's go ahead and work out the coordinates for this vertically shifted square. I would get an a value of 3 and a y value of 2, because I subtracted 3 from the 5, the y value of a. Moving on, I will get a b value of 6 and a y value of 2. Yet again, I subtracted the value of 3 from my y value of 5. Moving on to point C, I will get an x value of 3 and a y value of minus 1, because I subtracted 3 from the y value of 2 for point C. And moving on to point D, I will get an x value of 6 and a y value of minus 1, because I subtracted 3 from the y value of 2 for point D. I can now go ahead and plot this in. For A, it would be at an x value of 3 and a y value of 2. So I can do that. For B, it will be at an x value of 6 and a y value of 2. For C, it will be at an x value of 3 and a y value of negative 1. And for D, it would be at an x value of 6 and a y value of negative 1. And that is how I would shift this square downwards by 3 units. I manipulated its y value. Because the corresponding axis to a vertical shift is your y-axis. Now, using that same approach, if I wanted to induce a horizontal shift for this square, and I'm looking at the blue square, the first square that we worked with. I would have to manipulate its x values, because the corresponding axis to a horizontal shift is the x-axis. In order for me to manipulate that blue square to make it move 5 units to the left, 5 units to the left horizontally, I would have to subtract 5 from each x value of each coordinate. Let's go ahead and look at point A. For point A, my new coordinate would be -2 and 5. And the reason behind that is because I subtracted 5 from 3. For point B, I would obtain 1 and 5. For point C, I would obtain -2 and 2. For point D, I would obtain 1 and 2 for the y value. And I can go ahead and plot this in now. My new point A would be at -2 and 5. So I'm going to find -2, I'm going to move it up to 5, and I'm going to plot it there. My new point B would be at 1 and 5. So there's 1, there's 5, I'm going to plot it right there. My new point C would be at -2 and 2. My new point D would be at 1 and +2. And I can go ahead and sketch that in. And that is how we would approach a horizontal shift, guys. We simply manipulate the x values of the function, or the x values of the coordinate. Now, this approach is 100% correct, but when it comes to applying these two functions, we are going to do something a bit different. I just need to introduce you guys to what variable we are going to manipulate when we are trying to shift a shape horizontally, or shift a function horizontally, and that would be the x value of that function. You would also notice, guys, that in the series I will not be making a video for the horizontal shift of the linear function, and that is simply because the horizontal shift of the linear function is basically the vertical shift of the linear function, so you don't have to worry too much about that. We are going to jump straight into the horizontal shift for the parabola, and we will continue on to the hyperbola and the exponential function. That's it from me, guys. All the best, and I will see you in the next one.